afternoon, or good morning, or even good evening, depending on where you are, to all of you out there at the screens. On behalf of Miele Professional and DWK Life Sciences, I would like to welcome you to our today's webinar. Our goal for the next 60 minutes is to let you explore how high-quality glassware and automated reprocessing can enhance your lab processes. My name is Matthias Schmitz. I'm responsible for marketing, sales, and service of Miele Professional in Latin America, Middle East, and Africa. But today, it's my pleasure to be your moderator and to guide you a little bit through the next 60 minutes. Before we actually start, I would like to share some housekeeping topics with you. First of all, we will record this session. So if you would like to watch the webinar or parts of it again at a later point of time, you can do so. It will soon be available on the Miele Professional YouTube channel. This webinar is, of course, meant to leave you without any questions at the end. Hence, please share all your questions with us. For that, please use the Q&A function of this meeting and simply type in your questions there. We have reserved some minutes at the end of the session to answer them. And one advice, in case you are experiencing any issues with the sound or the visuals, try logging out and back in to refresh your connection. In almost all cases, that helps. And finally, we will be conducting the webinar in English, obviously. But if you feel more comfortable having subtitles in your native language, or of course in any other language, you can easily enable a live translation. Simply click on subtitles, then on turn on live subtitles, and then click on your language of choice. If you don't see the subtitles button up there, which is marked here with a 1 in the slide, then you need to click on the 3 dots right from it, and you will find it there. Please bear in mind, the subtitles will only be produced for the voice of the colleagues presenting here. The slides will, of course, remain in English. But now we're good to go. Let me introduce our experts who will share their insights with us today. The first one you are going to see and hear is Edmund Lowe. Ed is product manager at DWK Life Sciences, is based in the UK, and joins us today online to focus on the specific certificates, quality criteria, and reprocessing requirements of lab glassware. Welcome, Ed. The second part will be done by Ramona Diekert and Michael Sedlak here live on stage. Ramona is product manager for laboratory solutions at Miele Professional, and Michael has been responsible for Miele Professional's product management for laboratory, medical, and dental for more than 20 years. He's a member of the expert group AK Lab and co-editor of the laboratory glassware reprocessing publication, which you will see later. So you see, we have a great wealth of expertise here today, and now enough housekeeping, enough of introduction. Now let's jump into content. So Ed, would you please take over and guide us through the specifics of high-quality glassware? Thank you.
Yes, of course. Thank you, Matthias, for the kind introduction. Let me share my slides before we commence. Okay. So thank you again, Matthias, and thank you to the Miele team for giving DWK Life Sciences the opportunity to present on glassware safety tips and tricks. Hello, everybody. A good day and a good evening to you all. My name is Ed, and I'm the product manager of Lab Essentials and Volumetrics at DWK Life Sciences. I'm based in the UK, and I will be presenting on behalf of DWK Life Sciences today. So safety in the laboratory has always been a core focus for DWK Life Sciences. In this presentation, we'll explore how safety begins with quality laboratory glassware. High quality glassware ensures chemical resistance, temperature tolerance, thermal shock resistance, and mechanical durability. These attributes are essential for frequent and effective cleaning. compatibility with the lab washers, and maintaining hygiene and sample integrity. So ultimately, they help extend the lifespan of your glassware and support a safer, more reliable lab environment. So DWK Life Sciences is headquartered in Wertheim, Germany. We are a leading global manufacturer for laboratory glassware, and we provide life science and pharma packaging solutions. We are also a supplier of leading laboratory plasticware with 13 manufacturing sites and distribution centers worldwide, and just under 2,000 employees and 30,000 products within our portfolio. The timeline you see here indicates that DWK Life Sciences traces its origins back to 1887, when Otto Schott revolutionized glass manufacturing with the invention of borosilicate 3.3 glass. And over the years, through a series of mergers and acquisitions, we have evolved into the company known today as DWK Life Sciences. Now let's move on to an introduction to glass. In this section, we'll cover types of glass and composition, the features and benefits, and also some properties of glass. There are two main types of glass commonly used in laboratory glassware. On the left-hand side of the slide, you see soda lime glass. This type is typically used for disposable items like pasture pipettes and culture tubes. Its applications generally do not involve heat and don't require high chemical resistance. The composition of soda lime glass is relatively simple, consisting of sand, soda, and lime. And then on the right-hand side of the slide are some bullet points on borosilicate glass. So borosilicate glass, unlike soda lime glass, is more robust. It tends to be the preferred material for most laboratory glassware, used to manufacture a wide range of products, including beakers, volumetric flasks, and chromatography vials. Its key advantage lies in excellent thermal and chemical resistance, and it's ideal for heating and handling solvents. And unlike soda lime glass, the borosilicate contains boric oxide, which imparts elasticity and enhances durability of the glassware. Here on the left-hand side of the spectrum, again, you see soda lime glass, which has a relatively high coefficient of expansion of around 9. This makes it less suitable for applications involving heat or rapid temperature changes, as mentioned before. Its composition and properties are not as tightly regulated. Borosilicate products, on the other hand, are highly regulated by ASTM, USP, and ISO standards. Borosilicate glass is available in 2 classifications, so 3.3 and 5.1. And these numbers, they refer to its to the borosilicate's coefficient of expansion, or COE for short. So the COE measures how much a material changes in volume when exposed to temperature variations. A lower COE indicates better resistance to thermal stress, making the glass less prone to cracking under sudden temperature changes. For this reason, borosilicate 3.3, as seen in the right-hand side of the spectrum, is the ideal choice for ensuring safety and quality in laboratory environments, owing to the lower COE. Borosilicate has been tried and tested in the pharma industry. It's tightly controlled and has high purity as defined by the absence of heavy metals, for example. So ultimately, borosilicate 3.3 glass provides superior safety, quality, and data integrity. Glass has some great characteristics, all combined in one single material, which means you can use one container for many purposes. So the first feature you see here is that glass is highly transparent. So that's why historically alchemists used glass to observe reactions taking place inside the container. For example, when attempting to convert lead into gold. It's got excellent chemical resistance. It's impermeable to gases, which is extremely important to some applications in chemistry, where you have materials that are sensitive to gas. A glass, especially borosilicate 3.3 glass, has very good thermal shock resistance owing to the low COE that we talked about earlier, but also an even wall thickness if manufactured correctly. So the evenness of the wall is really important as well. With all these features combined, you can go all the way down to liquid nitrogen temperature and all the way up to several hundred degrees. As a material, glass forms a rigid, strong, and stable container, as well, as I'm sure many of you already know. If you look at the inherent properties of glass, so it all stems from the structure, which is a highly disordered amorphous network that is neither a liquid nor a solid. There are pros and cons to this amorphous network, with the advantage being that its softness and flexibility when heated benefits manufacturing. The disadvantage, on the other hand, is that within this amorphous network, the glass doesn't contain planes of atoms that can slip past one another to relieve stress, making the glass brittle. So when exposed to excessive stress, it can form cracks or fractures and even leads to surface flaws or the glass that explode if not handled properly, leading to injuries. So how can we avoid damage or avoid adding stress to the glass during routine lab usage, one might ask? Well, a strong starting point is adopting best practices alongside the use of safety products. First things first, when the glassware arrives, or before you use it for your experiments, the user should inspect it first. So make sure to wear protective equipment or PPE to protect your eyes, face, and skin. Use a black and white backdrop and flicker-free lights to improve visibility when inspecting the glass. And look out for flaws in dimensions, chips, cracks, and blisters. Obviously, if visible damage is present, you need to dispose of the glassware accordingly and also contact the manufacturer for further guidance. Some common failure modes in glass include cracking, fracturing, surface flaws, abrasion, thermal shock, and even explosion. We will now look at ways to mitigate the risks associated with glassware. First, we'll dive into how we can mitigate risks from mechanical stress or mechanical risks from mechanical stress. Always try to avoid glass-to-glass contact. Place items on shelves or in cupboards. Keep items away from shelf edges to reduce risk of knocking them over. Use bubble wrap or cardboard compartments, especially when transporting glassware from one place to another. Avoid scratches from tools such as wire brushes, abrasive pads, and metal spatulas. Instead, use tools and clamps that are plastic or rubber coated to avoid scratching of glassware. Last but not least, clamp the glassware properly in the right position to avoid stress. So you need to know your glassware well in order to know which is the right position. Or contact the manufacturer if you're ever in doubt. This one's a classic, the tilting of the HPLC bottle in analytical labs. We see this a lot, but don't do this. The user should use a product with a conical base reservoir to avoid falls and spillages. When carrying heavy bottles from one location to another, the user should use a bottle carrier. This is actually a mandatory practice in many laboratories and enforced by health and safety managers in many laboratories in the field. Choose products with an ergonomic design. Ergonomics is now a massive buzzword and is considered to be a mega trend within the laboratory and pharma subsegment. And we always try to develop new products to help the safety and user friendliness of products. You may consider using heavier duty glassware, like the super duty one here, which increases the mechanical robustness, especially of the walls and also the rim of the glassware. Choose flasks with plastic hose connectors if possible. And when using filtering flasks, and putting a tube onto the glass arm of the filter flask. Wear gloves, be gentle, and lubricate the side arm if needed. We also recommend the use of polymer-coated glassware. They're worth considering for added safety. So the coating helps prevent scratches and glass-to-glass contact damages. And if the glassware is dropped, it holds the pieces together and gives you extra time to safely transfer the contents into a new container. In terms of mitigating risks during temperature applications, we recommend heating up to 400 degrees Celsius, though 500 degrees Celsius is also possible for a short period of time. Apply a gradual and stepwise and uniform temperature change to avoid any thermal shock. Avoid going from 0 to hero straight away, so always go stepwise and slowly from one temperature to another before going to the highest temperature you want to go into for your experiment. Hot glass looks the same as cool glass, so don't touch, or at least wear a pair of heat-resistant gloves or use tongs to prevent burns. Always use a water bath for even heat distribution if possible. If using a hot plate, start on the low setting or medium heat setting to avoid excess localized heating. So this is the same principle as we said before in terms of applying a gradual, stepwise and uniform temperature change. Last but not least, some schools, especially in the UK, a lot of schools are still quite adamant on using a Bunsen burner for their experiments, mostly for cost reasons, in which case try to recommend against that, or at the very least, use a wire gauze to help diffuse the heat. Now, in terms of mitigating risks, again, from changing temperature, despite Super Duty's mechanical strength that we mentioned earlier, the thicker glass actually has less thermal shock resistance. So for heating applications, the user should use standard glassware for heating. And also bear in mind that the evenness of the wall thickness distribution is also very important, as mentioned before. So the evenness increases stability and thermal shock resistance. For chemical applications, borosilicate 3.3 is an excellent choice because it resists most chemicals. Only highly aggressive chemicals at elevated temperatures like hydrofluoric acid can degrade the glass. When cleaning with alkali-based agents, keep the temperature at around 70 degrees Celsius and use short cycles. Also avoid glass-to-glass contact in lab washers, as this can cause damage to the glassware. For pressure applications, use pressure or vacuum-rated products that enhance robustness and safety. When autoclaving, some liquids are prone to foaming, so only fill up to 75% capacity to allow for liquid expansion to prevent any overflow. And when autoclaving, the screw cap should only be loosely fitted because a tightened container could explode. When cleaning, again, inspect before and after cleaning. Use an automated washing machine if possible. Of course, our Miele team will dive into that in more detail in a second. Don't use abrasive cleaners that can scratch the glass. And don't use strong alkalis or strong acids as the cleaning agent. So throughout a typical automated reprocessing program, your glassware will be exposed to cold or hot water with alkaline cleaning chemicals or even acidic neutralizers, different water types and temperatures that can go up to 100 degrees Celsius when drying. This is why you need your glassware to be highly resistant to chemicals, high and low temperatures, and thermal shock. These properties stem from quality, which lead to safety and process improvement. There is nothing more important than making sure that everyone goes home safe at the end of the working day. So thank you for everybody for listening. As a summary, again, be aware of the manufacturing and quality processes. Safety and performance begin with the quality of the glassware. Use specific glassware for specific applications. And today we went through some ways we could mitigate risks from mechanical stress, thermal shock, chemical applications, and pressure applications. and hopefully they can be correctly applied in your day-to-day work or your customers' day-to-day work. So thank you for your time today. We have plenty more information on the website. Please feel free to visit us via dwk.com, LinkedIn, WeChat, exhibitions worldwide. We travel a lot, or even contact me directly if you need anything at all. So take care for now, and I now hand back the stage to our Miele team. Thank you.
Valuable information about your high quality glassware. Very much appreciated. Dear guests, in the second chapter of our webinar, we want to talk about the processing of laboratory equipment now. We want to make you familiar with the basic principles of laboratory glassware cleaning, and we want to explain to you which factors have a positive or negative influence on a good cleaning result. Cleaning laboratory glassware is a daily duty. It's a very important task because all labs all over the world need analytically cleaned lab glassware to be able to carry out the next analysis. So it's really important that we take care of what we are doing to achieve the right results. But that automatically also leads to the question, what is clean? Here's our definition. The contamination and all the process chemicals and the used water must be removed to such an extent that the previous application and also the cleaning process have no influence on the subsequent use of the laboratory equipment. You see, we are not only talking about the removal of soiling, we also have to think about all the factors that go into the cleaning process have to be removed afterwards so that you really achieve brilliant glassware. And the important thing is that each lab assistant or lab manager defines their own acceptance criteria for a cleanliness level. So there's no statistic or no checklist you can follow. It's really depending on your quality management system and the application, what kind of cleanliness level you want to achieve. What we can share today with you is our experience that a lot of Miele customers choose visually clean laboratory glassware as their acceptance criterion. So that's a very easy and cheap way to measure cleanliness, but it's very useful for most applications. But of course, there can also be other level of cleanliness, and therefore you need also different methods to measure the level of cleanliness. We don't have the time today, unfortunately, to explain those in detail to you, but we can make the announcements that there will be a specific webinar with the title How Clean is Clean, which we will conduct in August this year, where we will do a deep dive on the cleaning level and their acceptance criteria. So, cleaning laboratory glassware is a challenge, and why is that? On the one hand side, you want to achieve a thorough cleaning. That's pretty clear. But on the other side, you also want to be as gentle as possible to your lab glassware items as to prepare and also to retain the value as these products are very expensive. And it's a kind of challenge in that way as you have to consider that you have a lot of different types of lab glassware items that need to be processed sometimes in the same batch in a laboratory washer. You see here a range of laboratory glassware. One we call standard lab items, and there are also exceptional lab goods that go in the same chamber, for example. Secondly, you also have to consider the different sizes and volumes that have to be reprocessed, for example, in one shift. There can be very tiny items up to very large-scaled flasks, for example, or bottles, like in my example. And the third part is you also have to consider the material that this lab glassware was made of. On the one hand side, you have this borosilicate glass, And on the other side, you may also have plastic goods. And it's pretty clear that laboratory borosilicate laboratory glassware is more resistant to heat and chemistry compared to plastic goods. And last but not least, there's this huge diversity of soilings that you need to be aware of. That can be limescale, that can also be waxes, oils, it can be fats, agar, certain culture media, for example, and many, many more. And of course, you always have to choose the right program with the right chemistry, the right temperatures for cleaning to really achieve good results. We'll come back to that in a minute. So you see, cleaning lab glassware is on the one side a challenge and very much really underestimated how valuable this process is for a lab. You might ask yourself, yeah, how can they do it best? What is the best way to achieve a good cleaning result? Is there some science or some experience available that I can use for my daily cleaning approaches? Yes, it's available. So in the 19th century, a chemist was born. His name was Herbert Zinner, and the so-called Zinner circle is quite famous. And he made two statements. First of all, he said, okay, when you do a cleaning job, you always have to consider four factors that always go in. First of all, you have the factor temperature. It's pretty obvious that hot water or warm water provides a better cleaning result than cold water. When you wash your hands, you can experience this effect. Secondly, you always have mechanics as a factor in this interplay. That can mean a certain water pressure, or you use a brush for cleaning, for example. And so this is one factor to consider as well. The third one is detergents. Very powerful. Detergents help to dissolve the dirt from the surfaces and keep it in suspension. And if this detergent has also some disinfectant as part of it, then it also helps you to kill bacteria. And last but not least, the time as a very important factor, because it's pretty clear the longer exposure time you have, the better the cleaning result will be. So please be aware of these four factors. And the second statement Mr. Zinner made was to say it's possible to reduce one of these factors, but then at the same time, to achieve the same cleaning result, you have to extend at least the effect of one of the other. Let's do a short example. For example, you have an existing cleaning process with a lab washer where you use a cleaning temperature of 55 degrees Celsius. If you decide that you want to implement a process with less energy, you decide maybe to clean with 40 degrees Celsius only to save some energy, to have a reduced CO2 footprint. But that would mean to achieve the same cleaning result, you have either to extend the mechanics, so that means adding more force, more water pressure, for example. You also can use a more aggressive detergent or a higher concentration of detergent, or you have to accept a longer exposure time to come to the same level of cleanliness. So whatever you do, please consider that you have to bear in mind these four factors. And speaking about factors that go in our considerations, the water quality and also process chemicals are important too. I will explain to you why. Let's start with the water quality. A lot of labs use tap water, drinking water, for processing lab glassware. That can be done because it's really a cheap resource, but on the other side, the cleaning result that you can achieve by doing so will not be excellent. It's because as drinking water contains a lot of different material and parts that really are not beneficial for cleaning purposes. What you have learned from the slide before, warm water is always better than cold water. Secondly, we speak about softened water. Softened water has a certain hardness and is ideal for cleaning processes in a machine. That's also why the majority of lab washers contain an integrated water softener system, which can be connected to tap water, but in this water softener, the water gets soft, and then it's usable for the cleaning purpose. And the third water quality I want to introduce you to is demineralized water. When you do a final rinse in your machine, before you start the drying process, then it's always recommended to use demineralized water. And as the name says, it's more or less free from any kind of mineral substances. So it's really pure water, and that really ensures that after the drying phase, you will not find any gray or white spots on your surfaces. So your glassware will be really shiny. If you don't know which kind of water quality you have in your lab, here are a few values you should be aware of or you should ask for. First of all, when we speak about softened water, then we speak about a hardness that is less than 4 degrees German hardness, or as an equivalent, less than 70 milligram per liter of calcium carbonate. In terms of chloride, there's always a recommendation to have a content of less than 100 milliliter per liter. That is really recommendable. How to find out how your water quality looks like? There's either the possibility to contact your local waterworks, they can tell you, or if you like, you can also buy a very cheap and very much available measuring tools that don't provide you always with an exact figure, but that gives you a range if you work with hard water or maybe with soft water, and that is always helpful. Speaking about process chemicals, we distinguish more or less between 3 different groups of process chemicals, and I want to start with detergents. And here we have 3 classes of detergents, very briefly speaking. And we distinguish them according to their pH value. pH is an abbreviation for Pondus hydrogeni, and it's a measure of the acidic or basic character of an aqueous solution. And starting with acidic cleaning agents, it means these are based really on acidics, and they're used when you want to reprocess and want to remove, for example, glassware with lime scale. You know that from your kettle at home probably, or your coffee machine, there from time to time you also have to use an acidic agent to get rid of the lime scale. Then the second group are the neutral agents, and they have a pH value between 6 and 8, and you can use them when you have soilings that are highly soluble in water. Then you don't need so much force coming from a detergent, so neutral agents are really then recommendable. And the third group, and that is the most often used group, are the detergents based on alkalinity. So it can be mild alkaline, alkaline, or high alkaline cleaning agents that have a pH range of 9 to 11.5. These are recommendable for a lot of different soilings, but if you use them, you need the second group of process chemistries, and these are neutralizers. The job of a neutralizer is, after the cleaning phase, to reduce the pH value that is still on the surfaces of your lab glassware when you finish the cleaning process. So a neutralizing agent brings it back into the neutral area. And last but not least, I would like to mention very briefly that there are additional components, for example, like defoaming agents, oxidation agents, or emulsifiers, for example. These are additives that might needed because to stabilize the whole process. For example, you would use a defoaming agent in those cases where your soiling reacts heavily with an alkaline detergent, and it creates a lot of foam in the chamber. And foam is not really beneficial to create and to achieve very good cleaning results. So with a defoamer, you avoid foam, you have stable water pressure, and with that, that ensures that you come to the required results. We don't have time to go over these different applications and soilings to make a recommendation which detergents or process chemicals to be used. But what I would like to show you as an example, this is an extract from a big table where in the first column you see the contamination or the soiling, and the following columns show the recommended consumables in the pre-cleaning, cleaning phase, or in the neutralization phase. And as you can not really read that in a minute, I would just make you aware of this brochure from the AK Lab group. It's an expert group that made recommendation how to process lab glassware in the right form. And here you find also on many pages this recommendation which consumables you should ideally use. At the end of our webinar, we will provide you with the matrix code, and with this matrix code you have a free download of this brochure. It's available in 4 different languages, and it's really for you, for your daily work, and it's a great help. And with that, we are coming now to chapter 3 of our webinar, where my colleague Ramona will now make you familiar with the different methods how laboratory glassware could be cleaned and which are the advantages or disadvantages.
Yeah, thanks, Michael. So I will continue with the question, how do we typically clean laboratory glassware? So traditionally, lab glassware is cleaned by hand, so scrubbing each item with a suitable brush, with a sponge, using tap water and cleaning agent. So that's the typical way. Some laboratories also use ultrasonics to further loosen the residues, and that's the manual and semi-automated cleaning. So the alternative to that is cleaning with a professional lab washer. That's what we call automated cleaning. So what's a professional lab washer? Essentially, a lab washer is a system that is designed to clean, to rinse, and if needed, also to disinfect and to dry the lab glassware. But let's make it more practical, and let's take a look at one of our lab washer examples here in our showroom in Gütersloh. So here we have our Explorer line, the PLW8604. It's designed for labs that want to move from manual cleaning to a solution that is more efficient, a solution that is more reliable. So the Explorer line comes with 2 loading levels. And what you see here is one of our most popular configurations for this model. In the upper basket, you can see 2 inserts for beakers. And then in the lower basket, we have 2 easy load modules with injector nozzles to properly clean the inner surface of the glassware. And the advantage of our easy load system is that you can place any item over the injector nozzle without needing to adjust the height of the glassware. So it makes the loading much more simple and flexible. So with this configuration, you can clean up to 24 beakers in the upper basket and then 36 narrow-necked items in the lower basket. Yeah, so that's the Explorer line model, and you can say it basically has everything a good, reliable lab washer needs. But as you probably also know, there are many different requirements in lab glassware cleaning. In laboratories, we have different applications. So we also have different lab washers available. And here behind me, you see some of our other models. To my right side, we have, for example, our expert line model. It's our more advanced solution for all types of laboratories, but also those having higher demands in terms of application. So the expert line is equipped with several specialized programs for different types of contaminations, for different types of glassware. Yeah, so that's the expert line. And then right behind me, you see our slimline model. And that's for laboratories that require a higher capacity, but have limited space. So it comes with 3 loading levels and has a capacity of around 192 narrow-necked items. So it's compact with 65 centimeters in width, but it's incredibly efficient in terms of capacity. So we could talk a lot about products, product details, and how the lab washers differentiate, but that's not the topic for our webinar today. So let's continue with the question that we often get from the market, and that is, can we also use a dishwasher to clean laboratory glassware? And the short answer is no. Dishwashers are not suitable to clean lab glassware. First of all, domestic dishwashers, they are not approved for laboratory use. They simply don't meet professional safety standards that laboratories require. They are also not designed for professional use. As Michael mentioned earlier, in lab glassware cleaning, we have different alkaline cleaning agents, acids for neutralization, and these can really damage the internal components of a domestic dishwasher. The valves, the dosing system, they are not made for these kinds of substances. Yeah, domestic dishwashers also have a much weaker circulation pump, so they are designed for cleaning dishes, but not complex laboratory glassware. So that need more precise and more powerful cleaning. Dishwashers also lack specialized programs that are needed for certain types of contaminations like inorganic, organic residues, agar, oils, etc. And then also for different types of glassware like pipettes, vials, they need different programs than available on a dishwasher. The loading system of a dishwasher is also not made for glassware. As shown in the little clip on the side, the lab glassware is not held securely in place, which is very important in lab glassware cleaning, and that is not given in a domestic dishwasher. You can see they are not held properly in the dishwasher. And dishwashers also don't have injectors, which are essential to properly clean narrow-neck glasses. So in the end, a domestic dishwasher cannot meet the requirements for properly cleaning lab glassware. Now there are many different aspects that play a role in cleaning laboratory glassware. And to really understand the differences between manual and automated cleaning, let's take a look at these aspects, starting with the most obvious one, the cleaning result. So when we wash glassware by hand, the cleaning result can vary significantly from day to day, from person to person. So some days the glassware comes out spotless, and then on other days, especially when we are in a hurry, we might miss a spot, or we skip a rinse. So manual cleaning is never completely consistent because so many parameters change. Does the cleaning agent reach the entire surface of the glassware? Yeah, the water temperature, or how often do you rinse? These are all parameters. If they are inconsistent, it can have an effect on the cleaning result, and if there's remaining contamination on the glassware. So, and even small residues left on the glassware, that has an effect on later steps like sterilization or even the subsequent tests, which can be very costly. And then in the end, also, some types of glassware, they are just difficult to clean, like biscometers, pipettes. There's always a higher risk that in these tighter areas of the glassware, we have remaining residues. So in automated cleaning, the entire cleaning process is from pre-cleaning, cleaning, rinsing, disinfection, and drying is completely controlled by the machine. Each program automatically uses the correct amount of water, water temperature, water pressure, dosing of the cleaning agent. So the factors of the inner circle that we heard earlier about, they are perfectly aligned for each program to achieve the best cleaning results. And the big advantage here is consistency. So every cycle delivered the same high-quality cleaning result, no matter who operates the machine, no matter what day it is. And that means the results are reproducible, they are standardized, and the process is validatable. And when it comes to complex glassware, that's not a challenge for a lab washer. As we saw earlier, we have these injector nozzles. And here is one example or an animation of our easy load system. It nicely shows how the water and the process chemicals are distributed very evenly and effectively to properly clean the glassware. And that's just one example of a shape. Also for other shapes of glassware, it had the same effect. Yeah, so how does the cleaning method have an effect on the lifetime of the glassware? Yeah, washing by hand can be surprisingly harsh on the glassware due to the chemical and mechanical stresses. So if the glass is exposed too long to strong alkaline cleaning agent, it can lead to glass corrosion. And the same with, if you brush the glassware too heavily, it can cause scratches and have an effect on the durability of the glassware. So with automated cleaning, the cleaning is much more gentle. The process parameters, they are defined in a way to create as little stress on the glass as possible. And the mechanical stress is limited due to the stable positioning of the glassware in the rack. And that sums up in a longer lifetime of the glassware and reduced replacement costs per year. Let's take a look at the safety aspects. So in manual cleaning, we have several steps from pre-cleaning, scrubbing, rinsing, and drying. And at every step, the individual who's doing the cleaning is exposed to different or possible toxic contaminations or infectious contaminations from the residues in the glass and to the process chemicals for cleaning the glassware. So there is in general a higher risk of burns, of allergic reactions, or other health-related issues. So overall, there is a higher risk throughout the process for the laboratory staff. In automated cleaning, your role is limited to loading the lab washer and unloading it. So, yeah, there is a lower chance of coming into contact with harmful substances, and there's no direct contact to chemicals. And that creates, a maximum protection for the staff. Now let's take a look at sustainability and how manual and automated cleaning have an influence on sustainability aspects. And to illustrate it, I have a little question for you. So how much water do you think is needed to clean 60 regular lab glasses by hand and using our Explorer line model? So in our test, it took 81 liters cleaning 60 lab glasses by hand. And that's tap water and DI water. Using our lab washer, the Explorer line, and the standard medium program of our Explorer line, it takes 32 liters for 60 glasses. That's 63% less water using a lab washer. And if you think about it, it makes sense. In manual cleaning, there's generally a tendency to overuse water, to overuse process chemicals. So if you calculate it for a year, using or cleaning 60 lab glasses each workday, 23 days per month, you can save around 8,700 liters of water. And think about 8,700 bottles of water. That's a lot of water that you can save. So a lab washer can really enable a laboratory to become more sustainable. So let's move on to efficiency. How much time do you think is needed to clean 60 regular lab glasses by hand and using a lab washer? Yeah, in our test, it took 58 minutes to clean 60 lab glasses by hand. So that's almost a minute per glass. With our Explore line, it takes 24 minutes in the standard medium program. So that's 59% less time using the lab washer. And again, if you calculate it for a year, you could save around 156 hours or 19.5 work days if you take an 8-hour shift. So that's almost a complete month of working that is given back to you per year if you are using a lab washer and if you have that kind of throughput. Yeah, that brings us to another aspect to efficiency, or in terms of efficiency. When someone spends 58 minutes at the sink, that's almost an hour lost to more productive work. So the 58 minutes can't be used for anything else. With a lab washer, you load the lab washer, you press start, and you walk away. So while the machine runs for 24 minutes, you are free to focus on more value-adding tasks. So in many labs, staff time is the most valuable resource, and shifting that time from manual cleaning to a more value-adding task can be a real efficiency gain for the laboratory. Yeah, so we covered many aspects, but some might be wondering, is automated cleaning really cost efficient? Let's take a look. So imagine a university lab with various applications. A large proportion of their glassware is used for simple water-soluble soilings, and they have about 120 beakers and flasks per day, and that are currently cleaned manually. And the lab runs 250 days per year. So for this lab, our Explore line model could be an interesting choice together with our standard accessory set APL W214. And to evaluate whether the investment in a lab washer makes sense for this laboratory, we considered personal costs, water costs, and process chemical costs, and then for automated cleaning, also energy, service, and the initial investment in the machine and accessory. So here's the cost development over 8 years. If we look at the gray line representing manual cleaning, we see very low initial investment costs. So all you need is a brush and some cleaning agent. But over time, the costs add up, mainly because of the personal cost and the process chemicals. Now let's turn to the red line and representing automated cleaning. And here we see higher initial investment costs for the lab washer and the accessory. But once installed, the operating costs, they rise much slower, thanks to the personal costs and the resource costs. So the two lines, they cross at about 1.6 years. And meaning the investment pays off in less than 2 years and continues to save money over the product lifetime. So I hope by now you have seen that automated cleaning is really valuable and it can enhance your lab processes. So it delivers consistent, reproducible results that manual cleaning just can't guarantee. Cleaning with a lab washer is much faster. It frees up time for more important tasks. It uses significantly less water and process chemicals. It helps to extend the lifetime of your glassware. offers maximum protection for the staff. Yeah, we looked at it. It causes that you are less exposed to harmful substances. And even with a higher initial investment, a lab washer pays off very quickly and delivers long-term savings. So to wrap up this section of the webinar, I would like to summarize it with a short video. And then we can go into the Q&A section together with Matthias. So thank you, everyone.
All right. Thank you once again. Thank you, Ed. Thank you, Michael. Thank you, Ramona. Now it's time to answer your questions, which you wrote in the chat. And I have my notes here. We found a few questions. There were a few questions first around language, so I hope this was all clarified in the meantime. And then there was basically one question: if Miele have an online lab glassware configurator to easily select inserts and modules for customer applications, and also that one was already answered in the chat. So the colleagues are currently working on that. We need to ask you for a little bit more patience, but it will be available soon. And there was another one, basically a question in Spanish, how to clean pipettes, if I'm not mistaken. I have to admit my Spanish skills are not good enough to answer that question now in Spanish, but I think it's only fair to answer it also in Spanish. So we will do that in writing in the chat later, so please bear a while with us, but the question will be answered precisely then in the chat in writing. And then I found two more questions, which are basically more like organizational questions, if I may say. And these were basically a perfect bridge to my next slide, because you will find the answers on the slide already. Let me start with the first one. There was the question: will you be distributing the presentation after the call? And the answer is yes. So that is number 3 here on the slide. We are recording the webinar, and it will be available on the Miele Professional YouTube channel latest by end of February. And by the way, on that YouTube channel, you will also find a lot more content around cleaning of lab glassware. So just search for Miele Professional on YouTube, and you will find it there. Then there was the question: the presenter showed a manual about glassware washing. Where can we obtain that literature? And I'm pretty sure you mean this brochure that Michael has shown before. This one is number 2 here on our slide. So you have 2 options, at least 2 options now. Either you directly scan the QR code, which you see here on our presentation, and then you will be redirected immediately to the right homepage of this AK lab, of this working group, and you can download it there free of charge. Or we will also put the link into the chat, and you can just click there, and will then be linked to the right homepage. And then number 1 here on our slide. We would like to provide you with a certificate of participation. During the registration process, you have been asked if you give your consent to be contacted by us after the webinar. If you have agreed that we are allowed basically to contact you afterwards, we will provide you with the certificate automatically by email. If you haven't done so, then I know Michael has put a message already into the chat. So then just give your thumbs up below this message from Michael in the chat, and we will provide you nevertheless with a certificate of participation then by email afterwards. And then finally, of course, if you have any further questions around lab glassware processing, cleaning of about high quality glassware itself, then please refer to our local partners who have invited you for the webinar today. Reach out to your local Miele or DWK representative and just stay in touch with Miele Professional and DWK Life Sciences via our social media channels, especially via LinkedIn. And now, finally, I would like to remind you about the next editions of our webinar series. In May, you will have the opportunity to see proven strategies for streamlined glassware cleaning. And in June, we will introduce best practices for eco-friendly glassware cleaning. So book your calendars, sign up today. You will also find the link in the chat. If you haven't done yet, do so best case now. And with that, I would like to thank you very much on behalf of Miele Professional and DWK Life Sciences, especially Ed, Ramona and Michael, but also all the other colleagues who were involved in preparing this session, for attending our webinar. Enjoy the rest of the day or the evening. Stay healthy. Goodbye.